In today's note, we're going to look at the characteristics of stars. So before we begin, we need to kind of know what a star is. You may already have an idea, or at least you know what they look like. But stars are hot balls of gases that emit energy in the form of light. So we see the sun as an example. If you didn't know, the sun is a large star. And you see them at night when you look up at the sky, but essentially they're just balls of gas in the space that are emitting light. And they can differ in brightness, color, and temperature. So we're going to look at those characteristics. So the first is color, and they can vary in color. From some examples are blue, yellow, and red. So you can see some examples here. Luminosity is another word for basically brightness. So luminosity is how bright a star is. And luminous objects appear brighter when they are closer. So if you ever have been camping or you've been outside in the dark and someone's had a flashlight, if they're far away, that flashlight seems very dim, but as they get closer, it gets brighter and brighter. And the same idea is true for stars. So apparent magnitude is a term that describes how bright a star appears to someone on Earth. So when you're looking outside at night and you take a look at all the stars, you're basically looking at the apparent magnitude, right? So you're looking at how bright they appear to be. And stars can appear to be the same brightness to us on Earth, even though they may not be. So again, when you look up at the sky, you may see no difference in all the stars. You may say they all shine with the same brightness, or they appear to have the same brightness, and that's fine because that's the apparent magnitude. However, the absolute magnitude is the actual brightness of a star. And so the absolute magnitude can differ between stars. And it's similar to what we talked about, or that example I just mentioned about the flashlight at night. When you're farther away, it doesn't appear as bright, but when you're closer, it appears to be, or it is brighter. So basically, stars that are as bright as our sun have a luminosity of 1. So it's almost like a reference. If a star has a luminosity of 50, that means it's 50 times brighter than our sun. So again, we can have stars that are brighter than the sun, although if you think about it at night, they don't appear to be any brighter because their apparent magnitude isn't as high. However, their absolute magnitude is that they are actually brighter. They just happen to be a lot farther away. Temperature. So hot stars are around 15,000 degrees Celsius and greater, and the temperature of a star determines its color. So you can see kind of the different examples here. The colors determine how hot they are. That's one characteristic or relationship. So looking at color, again, we just mentioned color is an indication of a star's surface temperature. So when we just saw on the last page how the color determined what the temperature was. Blue stars are hotter and red stars are cooler. So again, it's almost similar to the flame on a Bunsen burner. When we talked about in our demonstration, the blue flame meant it was hotter than the red flame. So just looking at some of the relationships between the characteristics. So looking at luminosity and color, brighter stars are blue, or they're hotter, or they're burning brighter. And dimmer stars tend to be red. So again, they're not as hot. They're not emitting as much light. Looking at size and luminosity, so size and brightness. So bigger stars are brighter and smaller stars are dimmer. So this one may be almost common sense, but the bigger the star is, the brighter it will be. Basically, there's more gas burning, more energy being emitted. And if we wanted to look at the composition of stars, or what they're made up of, we can use a spectrograph to analyze the spectrum. So we talked a little bit about this in the chemistry unit, about how elements can emit a certain spectrum, or the gases can emit a certain spectrum. Basically, we do the same thing with stars. So we use the spectrum that a star emits to tell us what elements are present. So an example here, these are the spectrums that you may see on different stars, and we would compare these spectrums to our references or our known spectrums of elements and try to match them up and see, okay, what elements would be present in these stars. So that's kind of one way that scientists can use elements on Earth and use those as a reference to what we see in stars. And again, that was just a quick overview of just some of the characteristics of stars, nothing too in-depth, just kind of a general overview of them.